Attributes and transformations of reciprocal functions, also known as inverse variation functions or the rational function parent function. So let's quickly look at this graph again, y equals 1 over x. If I create an xy table, let's choose some x values. I'm choosing -2, -1, -1/2, -1/4, 0, 1/4, 1/2, 1, and 2. My y values will be found by taking 1 over x. So for -2, I have 1 over -2. For -1, I have 1 over -1. For -1/2, I have 1 over -1/2, which is -2. For -1/4, I have 1 over -1/4, which is -4. For 0, I have 1 over 0, which is undefined. For 1/4, I have 1 over 1/4, which is 4. For 1/2, I have 1 over 1/2, which is 2. For 1, I have 1 over 1, which is 1. And for 2, I have 1 over 2. So looking at this graph again, let's plot some points. -2, -1/2, -1, -1, -1/2, -2, -1/4, -4. We don't have a point at x equals 0 because it's undefined there. 1/4, 4. 1/2, 2. 1, 1. And 2, 1/2. And if I draw in these branches in green, I have 2 separate branches that are not connected. I have 2 asymptotes. I have a horizontal asymptote on the x-axis and a vertical asymptote on the y-axis. I have no x-intercept, no y-intercept. The domain is x does not equal 0. The range is y does not equal 0. And the x-axis is a horizontal asymptote, and the y-axis is a vertical asymptote. So that's our parent function. Now let's look at some transformations. So first, let's look at some vertical stretches and compressions. So we'll have our parent function, f of x equals 1 over x, and then we'll have a function f of x equals 6 over x, and we'll have a function f of x equals 0.25 over x. So here we have all 3 graphs. The parent function is in black, and the red function, f of x equals 6 over x, is here in red, and this is a vertical stretch. So if we were pulling this graph on the y-axis away from the x-axis, it would stretch the parent function graph so that we could achieve f of x equals 6 over x. It's a vertical stretch. And then f of x equals 0.25 over x is here in blue, and this is considered a vertical compression. So in general, for f of x equals a over x, there's a vertical stretch when the absolute value of a is greater than 1, and a vertical compression when absolute value of a is between 0 and 1. Okay, let's look at a reflection over the x-axis. So again, we've got our parent function, f of x equals 1 over x, and we'll look at f of x equals -1 over x. So here on our graph, we've got the parent function graphed in black, and -1 over x is here in purple. And in general, when f of x equals a over x, when a is less than 0, like we have here, then it's a reflection over the x-axis. So our parent function is just reflected over the x-axis. Now, with this particular graph, if we look at reflection over the y-axis, so we've got our parent function, 1 over f of x equals 1 over x, and then f of x equals 1 over -x. That is going to be the same graph as our purple function that we had above. So with f of x equal to 1 over bx, when b is less than 0, it's a reflection over the y-axis, which actually looks identical to, with this function, it looks identical to a reflection over the x-axis. And that has to do with the rotational symmetry about the origin that our reciprocal function has. Okay, let's look at horizontal stretches and compressions. So we'll start with our parent function, f of x equals 1 over x. And then we'll look at f of x equals 1 over 5x. And then we'll look at f of x equals 1 over 0.1x. Here we see all three of our graphs. Again, the parent function's in black. F of x equals 1 over 5x is here in red. And here, this is a horizontal compression. So it's like pushing the x-axis on either end towards the y-axis, so towards the center, towards the origin, and it's compressing it. Then f of x equals 1 over 0.1x, or 1 over 1/10 of an x, is here in blue, and this is a horizontal stretch. So in general, for f of x equals 1 over bx, for when the absolute value of b is between 0 and 1, we have a horizontal stretch. And when the absolute value of b is greater than 1, we have a horizontal compression. Okay, let's look at some translations. We'll start by looking at vertical translations. So again, we'll have the parent function, f of x equals 1 over x. Then we'll look at f of x equals 1 over x plus 2. And then we'll look at f of x equals 1 over x minus 3. So here's a graph with all three functions on it. The parent function is in black. F of x equals 1 over x plus 2 is here in red. And it is a vertical translation up 2 units. And you can see that the horizontal asymptote has also moved up 2 units to y equals 2. My blue graph, f of x equals 1 over x minus 3, is here in blue. It's got 2 branches, it's on the other side as well. And it is translated 3 units down. And now, as well, the horizontal asymptote is translated 3 units down to y equals negative 3. So in general, although for all three functions, you'll notice the vertical asymptote did not change. It is still on the y-axis, which is at x equals 0. In general, when we have a function f of x plus d, we're translating d units up. In the horizontal asymptote, also gets translated up d units to y equals d. And if we have f of x minus d, we are translating d units down, and the horizontal asymptote becomes y equals the opposite of d, or negative d. And finally, let's look at horizontal translations. So we'll look at our parent function, f of x equals 1 over x. We'll look at f of x equals 1 over x minus 2. We'll look at f of x equals 1 over x plus 3. Here's our graph. Again, the parent function is in black. F of x equals 1 over x minus 2 is here in red. And this is a translation 2 units to the right. You'll notice that here the vertical asymptote shifts 2 units to the right to be x equals 2. I'm saying it's shifting to the right because the parent function starts at x equals 0, so it's going 2 units right. Now if we look at f of x equals 1 over x plus 3, that's the function in blue, and that is being translated or shifted 3 units to the left. And the vertical asymptote is also shifting 3 units to the left to be x equals -3. And this time, all 3 graphs still have the same horizontal asymptote, which is at y equals 0, or the x-axis. In general, if we have f of x minus c, we are shifting c units to the right, and the vertical asymptote is shifted right as well to x equals c. If we have f of x plus c, we are shifting our function c units to the left, and our vertical asymptote also shifts to the left to become x equals -c, while the horizontal asymptote remains the same. Okay, let's look at an example of looking at a graph and actually writing the equation from the graph. So here we have a graph, and let's see if we can figure out its equation. Now I can see that it looks like there's a horizontal asymptote here at y equals -4, and it looks like I have a vertical asymptote here at x equals -5. So if I start with 1 over x, I'm shifting left 5, so 1 over x plus 5, and I'm shifting down 4, so -4. So the equation of the function we see here is y equals 1 over x plus 5 minus 4. And I mainly used the asymptotes to help me see how it was being shifted.